So today we're going to do some examples of time value of money. These should help you complete the homework assignment that is due in a few days. So I'm going to go through these with you one by one, and please feel free to reach out after you watch this recording if you still have any questions. So Philip has $1,000 in his savings account growing at 2% compounded annually. If he does not contribute anything for the next 10 years, how much will he have in his savings account? So his present value is $1,000. We're going to put that in our present value column. We don't know how much he's going to have in 10 years. That's what we're trying to solve for. Our rate is 2%, which is 0.02. Our payment, he's not going to put anything in for the next 10 years. And his NPER, which is his number of periods, is 10 years. So over here, we're going to come to our formula. We're going to do equals future value. And then you're going to click on your rate, your NPER, your payment of 0, and your absolute value of your present value. This gives him a value of $1,218.99. If he has $1,000 now, it grows at 2% for the next 10 years, and he doesn't contribute anything. So he would gain $218.99. So let's take the same example. You have $1,000 in your savings account. It's going to grow at 2% compounded monthly. So in this case, you want to do equals your rate divided by 12 because there are 12 months in a year. So that's going to give you your monthly rate. He's still not going to contribute anything, and his NPER is still going to be 10 years. So if we go over here and we figure out what the future value is, again, we're going to have our rate. We're going to have our NPER. Well, actually, I just made a mistake. His NPER is actually going to be 10 times 12 because he's going to have 120 months. He's going to have 10 years at 12 months a year is 120 months. That's his NPER. So let's try this again. Sorry about that. Your rate is going to be your 0.02 divided by 12. Your NPER is 120 months. Your payment is 0. And the absolute value of your present value gives him a difference total of $1,221.20. So if we look up here, if we took it compounded annually, we're going to get roughly $219. And if we do it monthly, we're going to get $221. So remember that going back to this, if the more compounding periods that you have, that's going to be your compound interest, which is going to build interest on interest, which is why you're going to have more money if you are compounding monthly compared to compounding annually. So let's go down here. Laura has $1,000 in her savings account. It's going to grow at 2% compounded monthly. So again, remember, we're going to do that rate divided by 12 because that will give us our monthly rate. She's going to contribute $100 a month for the next 10 years. And again, we're going to do 10 years times 12 months. So if we go over here and we do our future value, we're going to again click our rate, our NPER, our payment, and our absolute value. And that's going to give us $12,050.77. So just contributing $100 a month will give us quite a bit more money than what she would have had or what William would have had per se, not contributing anything to his account. So let's go up here to Jenna. She wants to have $10,000 in her savings account in 3 years. So that's going to tell us our future value. If she currently doesn't have anything in this account, so that's her present value, how much does she need to save each month if her account compounds at 4% monthly? So again, we're going to take our rate and divide it by 12. Our NPER is going to be 3 times 12. for 36 months, and we're trying to figure out what our payment is. So our rate, and it tells you right down here what you need to put in the order. Your NPER, the present value is 0, and your absolute value of the future value. So she needs to have $261.91 to save each month if her account compounds at 4% monthly. So she's going to need to save $261 to have $10,000 in 3 years. So Jacob, again, wants to have $10,000 in his account in 3 years. He doesn't have anything in his account at this point, and he wants to, how much does he need to save each month if his account compounds at 4% annually? So this, we're going to figure it out annually, and then we'll multiply that by 12. His rate is 4%, his NPER is 3, present value is 0, and the absolute value of the future value. So that's going to, he's going to need this much per year. And if you take this divided by 12, he's going to need $266. So again, because his account compounds annually and not monthly, he's going to need more money per month than Jenna does with her account being compounded monthly. Now, Stephen down here, he wants to purchase a $20,000 vehicle. So $20,000 is the current value of the car. He doesn't want any more than a $375 payment. So we're going to put $375 down here in the payment area. And what interest rate does he require to obtain that payment if the loan term is 60 months? So our N is 60. We're going to solve for our rate. Your NPER is 60. Your payment is $375. Your present value is $20,000, and your future value is 0. Oh, I did something wrong. There we go. Make sure you have your absolute value of the present value. Now remember, this is a monthly rate. So we need to take this rate and multiply it by 12 months to get our annual rate of 4.73. So Anna wants to purchase a $25,000 vehicle. So that's our present value. Our future value is going to be 0. She's approved at her bank for a 60-month loan at 3.9%. So let's remember that if we're looking at 60 months, but a 3.9 annual, we need to change that rate to be a monthly rate. So then we're going to go down here and solve for our payment. There's our rate, our NPER, our present value, and our future value. So Anna is going to need to make a payment of $459.29 per month for a 3.9% loan. Brian wants to have $1 million at his retirement age of 65. So that tells me that that's his future value. Since that's so many zeros, I'm going to put that into dollars so we can see. If his rate is 3%, his current age is 21, what will that $1 million be worth in terms of today's value? So we're going to solve for our present value. We're not going to have any payments because he's not going to pay anything between now and then. But how do we figure out what that NPER is? Well, we know that he's currently 21 and he's going to retire at 65. So the difference between 65 and 21 is how long that money is going to sit there and accumulate. So we're going to solve for our present value with a rate of 3%, our NPER of 44 years, 0 payments, and our future value, our absolute value of the future value. So in today's dollars, Brian needs $272,371.78. This is how much he would need as of today to get to $1 million by age 65. So let's go down here and talk about Eric. So in contrast, Eric has $1 million right now. And again, we're going to format that so we can see it a little bit better. He wants to know what it's going to be worth at his retirement age of 65. He's never going to contribute, so our payments are going to be 0. And he plans to obtain a 6% rate of return each year until age 65. So again, what are we going to use for our NPER? Well, he's going to retire at age 65 and he's currently 21. So we're going to take 65 minus 21, gives us 44 years that this money is going to be able to gain interest. So we're going to find our future value. Our rate is 6%. Our NPER is 44. Our payment is 0. The negative absolute value, or the absolute value of our $1 million. And that means that Eric's $1 million today is going to be worth almost $13 million at age 65. So in 44 years, his 1 million is going to turn into $12,985,481.91. So as far as your homework goes, I'm going to talk about a few things here quickly to give you some tips and tricks. You will notice that in the examples that I just did, they want to retire at 65. Those are similar ages for Eric and Avery in problem number 1. So you just want to figure out where they're going to start, where they're going to end, and how many years that is to figure out how much they're going to contribute to their account and how much they're going to have at their value when they actually retire. In problem number 2, just remember that you want to divide your loan term, your rate, by 12 to get your monthly payment. And then you also want to solve for if you had a 0 APR, so you didn't have any interest on that loan, what would that payment be? And then the difference between those two would help you find the answer to part B. Problem number 3, just again, remember to do compounding monthly. So you need to take your interest rate and divide it by 12. Problem number 4 should be pretty easy. You just want to compare and contrast the APR and the effective annual rates. And again, problem number 5, make sure that you pay attention to the compounding period of whether it's annual or monthly. So that's all for today. And if you have any other questions, please feel free to reach out at any time. And I will talk to you all soon.